Let's practice multiplying and dividing fractions together. So for each of these practice problems, we're going to do 6 of them where we're going to be multiplying or finding the product of 2 fractions. And then we're going to go ahead and do 6 practice problems where we're dividing or finding the quotient of 2 fractions. All right, so for number 1, we have 3/4 multiplied by 8/9. And what we can do here is we can just go ahead and take the numerators and multiply them together. So we have 3 times 8, and on the denominator, we have 4 times 9. All right, so when you're multiplying fractions, you don't need common denominators. You can just go ahead and multiply across. So 3 times 8 on top is going to be 24. And then we have this 4 times 9 on bottom, which is going to be 36. All right, so this would be the product or the answer to a multiplication problem. However, we also have to see if we can go ahead and simplify this thing. So let's go ahead on the side and see. Let's go ahead and use the ladder method. There are different strategies for simplifying fractions, but I'm going to use the ladder method and just put the numerator and denominator next to each other. And this is a nice little way we can go ahead and simplify fractions here. So a common number you can divide here by is going to be, I don't know, I'll go ahead and say 6 here. But you can go ahead and check your multiplication facts or divisibility rules. 6 goes into 24 4 times, and then we're going to put this fraction bar. 6 goes into 36 6 times. Looks like for 4 and 6, you can go ahead and find another common factor though. Let's go with 2 here. So if we go ahead and put a 2 on the side, 2 goes into 4 2 times, and 2 goes into 6 3 times. All right, so this here on the side, 6 times 2, because I think we're done here, is going to be the GCF, and that's going to be 12. So let's go ahead and write, we're going to divide the top and the bottom both by 12 here. And if we go ahead and do that, we should get this fraction on the bottom, which is going to be our product. So this 2/3 on the bottom is going to be our answer. So let's go ahead and say the answer here is going to be 2/3. This is going to be our final answer. All right. All right, let's check out number 2. For number 2, we have another similar multiplication problem here. So let's take this 8/15 and multiply it by this 35/12. So let's go ahead and just multiply the numerators together. So we have 8 multiplied by 35 on top. And then on the bottom here, we're going to have 15 multiplied by 12. All right, cool. So let's go ahead and see if we can multiply these out. Now we might need to do some multiplication on the side here. But we can go ahead and take this 35 and multiply it by 8. 35 times 8 here, well, that's going to be 40. I'm going to go ahead and carry the 4. And then we have 3 times 8, which is 24, plus the 4, which is going to be 28. So our numerator here is going to be 280. And what about the denominator? We have 15 times 12. So we're going to take 15, multiply that by 12. 5 times 2 is going to be 10, carry the 1. 2 times 1 is 2, plus 1 is going to be 3. I'm going to put a placeholder here. 1 times 5 is 5, then 1 times 1 is 1. Go ahead and add these together. We're going to get that we have 180. So that's going to be our denominator. Okay, so this would be our product, but we have to check to see if we can go ahead and simplify this thing. So let's go ahead and take this 280 over 180, and let's see if we can find some common factors to go ahead and simplify this down by. I think I'm just going to start with 10 actually. So we can use 10, this becomes 28 and 18. Just drop the zeros basically, right? And then we can go ahead and go again here. They're both even numbers. I'm going to divide them both by 2. I'm going to get 14, and I'm going to get 9 here. All right, don't think we can simplify any more here. So on the side, this would be our GCF. That's going to be 20. So we can go ahead and divide the top by 20 and divide the bottom by 20. And what are we left with? Well, we're actually just left with these bottom numbers here, right? So that's just going to be this 14 over 9. So I'm going to go say this product here is going to be equal to 14 over 9. All right, that'll be our answer. So I'm going to say this is going to be 14 over 9. And if you wanted to write it as a mixed number, you could also say this is going to be 1 and 5/9, right? Both of these are okay. For number 3, we have some mixed numbers here. So the first thing we're going to do is we're going to want to convert them into improper fractions, right? So let's go ahead and take this 1 and 7/9. If we do 1 times 9, that's going to be 9, plus the 7 on top, that's going to be 16. So we can rewrite this 1 and 7/9 in improper form, which is going to be 16 over 9. And we're going to go ahead and multiply that by, let's see, this is another mixed number. So 4 times 2 is 8. 8 plus 1 is going to be 9. So it's going to be 9 over 2. All right, so let's go ahead and rewrite this. We can go again and just multiply the numerator. So it's 16 times 9 over 9 times 2. All right, and so if we go ahead and multiply here, I think on the bottom, I'm just going to write it's 18 right away. Hopefully that's okay, 9 times 2. And for the top, 16 times 9, I'll go ahead and do that on the side just in case here, 16 times 9. 6 times 9 is going to be 54, carry the 5. Then 9 times 1 is 9, plus the 5 is going to be 14, so we have 144. So looks like our numerator here is going to be 144, and it's over 18. All right, I think we might be able to simplify this, right? Because we use our divisibility rules. These are definitely both even numbers. So let's go ahead and take this 144, and let's see if we take this 18 and set up our ladder method. I think we can divide by 2. This 144 is pretty big. So half of 144 is going to be 72, and then half of 18 is going to be 9. All right, these are a little bit more manageable now, right? These numbers aren't too big. I think I would actually divide these both by 9, right? 9 goes into 72 8 times, because 9 times 8 is 72, and 9 goes into 9 1 time. So we can see here that our GCF, 9 times 2 on the side, is going to be 18. So that means we can divide the numerator and denominator both by 18. And if we do that, we're going to be left with just this 8 over 1 over here, which 8 over 1 is improper, and 8 over 1 is just equal to 8. So we can leave our final answer here, our product, as 8. All right, let's see. For this next example, we have another mixed number multiplied by a mixed number. So let's go ahead and do big bottom plus the top. So 5 times 5 is going to be 25. That's big bottom. Plus the top here is going to be 27. So we're looking here at 27 over 5. And we're going to go ahead and multiply this by the improper version of this 4 and 1, 6. So big bottom, 4 times 6 is 24, plus the one on top is going to be 25. So we're looking at 25 over 6. Okay, so we're going to multiply these together, and on top we have 27 times 25, and on the bottom we have this 5 times 6. Now, I know 5 times 6 is 30, so I'm just going to go ahead and write that 30 right away. But the 27 times 25, let's go ahead and take a moment and do that on the side here. So if you need scratch paper, use some scratch paper. But 27 times 25, we have 5 times 7 is 35, carry the 3. We have 5 times 2, which is 10, plus the 3, which is going to be 13. We get a placeholder over here. Then 2 times 7 is going to be 14, carry the 1. Then 2 times 2 is 4, plus 1 is going to be 5. So we're looking here at, let's see, a 5, a 7, and a 6. So I think it's going to be 675 for the numerator. Okay, so the question is can we simplify this? Well, I think we can, just because both numbers here end in 5 and 0. So I think we can divide them both by 5 using our divisibility rule. So let's take this 675 over 30. Oops, go ahead and rewrite that 0 here. And let's go ahead and divide these both by 5. So if you take this 675 and you divide that by 5, I think that's going to be 120 plus 15, 135. So I'm going to put 135 down here. And then 30 divided by 5 is going to be 6. Now, if we take a look at these two numbers here, we can't divide them by 2, but maybe 3. Use your divisibility rule for 3. 1 plus 3 plus 5 is 9, and that's a multiple of 3. So we can definitely divide these both by 3. Now, 135 divided by 3 is going to be 45, and then 6 divided by 3 is going to be 2. Now, 2 doesn't go into 45. I don't think they have anything common here, right? So if we go ahead and see on the side, our GCF is going to be 15. 3 times 5 is 15. So if we divide these both by 15, please, again, don't do any long division here. It's just going to be 675 divided by 15 is 45, and 30 divided by 15 is going to be 2. So writing our product here, we could say that as an improper fraction, we could just say it's going to be 45 over 2. But if you wanted to write it as a mixed number, you could and say this is going to be 22 and 1/2. All right, let's check out number 5. For number 5, we have 1 and 13/15 multiplied by 20. So we have a mixed number here and a whole number. So for the mixed number, let's do big bottom plus the top. So 1 times 15. So big bottom is going to be 15 plus the top. 15 plus 13 is going to be 28. So for the numerator here, we're going to get 28. And for the denominator, we're going to keep that the same. It's going to be 15. And then for the 20, as a fraction, we can just write 20 as 20 over 1. Don't worry about getting any common denominators because we don't need to when we're multiplying. Now, if we go ahead and multiply the tops here, it's going to be 28 times 20, right? And on the bottom, we're going to have 15 multiplied by 1. So on the denominator, 15 times 1 is just going to be 15. But for the numerator, what about 28 times 20? Well, let's go ahead and do 28 times 20. It's really just 28 times 2, and you can add a 0 on, but I'm just going to write it out just in case. So 0 times 8 is 0. 0 times 2 is 0. Put a placeholder. 2 times 8 is going to be 16. Carry the 1. 2 times 2 is 4, plus 1 is going to be 5. If we go ahead and add these up together, we're going to get 560. So our numerator is going to be 560, while our denominator is 15. Let's go ahead and see if we can simplify this. So let's take this 560 over 15 and see what we could divide both of these numbers by. Now, they both end in 0 and 5, so my first instinct is just to go with a 5 here. And if we do 560 divided by 5, you're going to go ahead and get 112. So put 112 down here, and then 15 divided by 5 is going to be 3. Now 3 is a prime number, and it doesn't go into 112 because 1 plus 1 plus 2 is equal to 4. So I think we're going to be stuck here, which is perfectly fine. That means we're done. So our GCF here is going to be 5. So let's go ahead and divide both top and bottom by 5 over 5. And we're going to be left with this as our product here, this 112 over 3. So our answer here is going to be 112 over 3. And if you wanted to write this as a mixed number, you totally could. We could just go ahead and take this 112 over 3, and we can go ahead and just perform some long division. So 3 doesn't go into 1, but it goes into 11 3 times. 3 times 3 is 9. We can subtract here, get 2, bring down this 2. 3 goes into 22 7 times. 7 times 3 is 21. We get a subtract, we get a remainder of 1. So you could also say this would be 37 and 1/3. Right, that would be the mixed number version for this product. All right, let's go ahead and try one more multiplication problem here. Here we have a mixed number multiplied by another mixed number. So we have this big bottom 5 times 15, that's going to be 75. 75 plus 2 here is going to be 77. So we're looking at 77 over 15. We're going to be multiplying this by, let's convert this one into an improper fraction too. So 3 times 7 is going to be 21. 21 plus 3 is going to be 24. So we're looking at 24 over 7. All right, so we're going to have to find the product here of the numerator, so 77 multiplied by 24, and find the product of the denominator, so it's going to be 15 multiplied by 7. All right, so we're going to need to do some multiplication here. So for the top, it's going to be 77 by 24, right? So let's see, 77 multiplied by 24. It's going to be pretty big here. 4 times 7 is going to be 28, carry the 2. 4 times 7, again, is 28, plus the 2 is going to be 30. Let's put a placeholder here. 2 times 7 is going to be 14, carry the 1. 2 times 7 is 14 again, plus 1 is going to be 15. All right, so if we go ahead and add these up together, we're going to get 8, 4, 8, 1. So I think that's going to be our new numerator for the product, 1, 8, 4, 8. And then for the denominator, we have 15 times 7. This one's going to be not as bad, or not as much work. So 15, 7 times 5 is going to be 35, carry the 3. Then 7 times 1 is 7, plus 3 is going to be 10. So it's going to be 105. All right, so these numbers are pretty big, but let's go ahead and see if we can see what we can divide these both by. Let's go ahead and set up this ladder method, this 1, 8, 4, 8, and this 105. All right, so let's go ahead and see what we can divide these both by. This ends in a 5 and this ends in an 8, so we can't divide these both by 5 or 10. We can't divide them both by 2 because this is an even number and this is an odd number here. What about 3? Well, 1 plus 8 is 9. 9 plus 4 is going to be 13. 13 plus 8 is 21. So 3 does go into 21. And then 1 plus 0 is 1, plus 5 is 6. So 3 does go into 6 as well. So we can definitely divide these both by 3. So let's go ahead and do that. If we take this 1, 8, 4, 8 and we divide that by 3, feel free to pause and do the long division, but you're going to get 616, 616. And for the 105, if you need to divide that by 3, that's going to be 35. All right, so these numbers are definitely smaller. I think we can go again here, but I'm going to go ahead and go through my divisibility rules. 35 is a nicer number, so I'm going to see, I can divide that by 35 and 1, definitely. And I can divide this by 5 and 7. So 5 won't go into 616, but maybe 7 will. Let's see, if we use that rule for 7, you could just divide it to try, or double this last number, which is 6. Double that, that's going to be 12. And if you take away 12 from 61, that's going to be 49. And so that is a multiple of 7, so we can definitely divide this 616 by 7 here, okay? So again, feel free to pause to do the long division as needed to try this out, but 616 divided by 7 is going to be 88. And if we take this 35 and divide it by 7, it's going to be 5. Now, 5 is a prime number, and it doesn't go into 88, which means we are done. On the side here, 7 times 3 is 21, which means that's the GCF. If we divide these both by 21, we're going to get our final answer here of 88 fifths. So that right here would be our product, 88 over 5. Now, we can go ahead and write this as a mixed number too. For 5 going into 88, I can go ahead and write this division out just so you can see, just to practice. 88, let's see, 5 goes into 8 one time. 1 times 5 is 5. 8 minus 5 is going to be 3. If you bring down this 8 here, 5 goes into 38 7 times. 7 times 5 is 35, sorry. And then we subtract here, we're going to get 3. So what would our mixed number version be? It would be 17 and 3 fifths. All right, cool. So there you have 6 different practice problems with multiplying fractions. And after we multiplied, we had to also just make sure we could simplify each of our products down so that it's as simple as possible to look at those numbers. We always want to have the smallest numbers possible in the end. All right, let's try 6 practice problems where we're going to go ahead and practice dividing now. All right, so when we're dividing fractions, we also just want to have improper and proper fractions. So for number 7, we should like this one right away. So it turns out for dividing fractions, our algorithm is going to be that we will turn it into a multiplication problem, right? So for each of these problems, we're going to rewrite these as multiplication problems, but if you solve that multiplication problem, you will get the answer to the original division problem. So it sounds a little confusing, but you can rewrite all division problems as a multiplication version, and multiplication is a little bit easier to kind of wrap our minds around in general. So what we're going to do is I'm going to use this acronym of keep, change, and flip, or KCF. So we're going to go ahead and keep this first fraction of 9 over 10. And we're going to change division to multiplication. And then we're going to flip or write the reciprocal of 27 over 25 and rewrite it as 25 over 27. All right, so that's going to be the first step, and is just keeping the first fraction, changing division to multiplication, and then flipping that second fraction upside down. So this is always going to be our first step if we just have proper and improper fractions. If in the future we have mixed numbers or whole numbers, let's just make sure we turn them into propers or impropers before doing this step. Okay, so let's go ahead and multiply these out. I'm not going to rewrite this as like kind of one fraction, but I'm just going to go ahead and multiply 9 times 25. So let's do 25 times 9. That's going to be 45, carry the 4. 9 times 2 is 18, plus the 4 is going to be 22. So we're looking at 225 for that numerator. All right, for the denominator, it's 27 times 10, so that's really just 27 times 1, but then put a 0 at the end, so it's going to be 270. All right, now can we simplify this? I definitely think so, because we have a number that ends in a 5, and we have a number that ends in a 0, so we can definitely divide these both by 5. So it's good to know that divisibility rule. So dividing this by 5, 225 divided by 5 is 45, all right? And if you take this 270 and divide that by 5, we're going to end up with 54. Now what about 45 and 54? Both their sums of their digits add up to 9, so we can definitely divide them both by 9. 9 times 5 is 45, and 9 times 6 is 54. All right, so this 5 and 9 on the side make 45. 45 is going to be our greatest common factor, or our GCF, so we can divide these both by 45. And then at the bottom here, we have our 5 and our 6, which is our most simplified fraction here. So we're going to get 5/6 as our quotient. We just found out that this fraction of 27 over 25 fits into 9/10, 5/6 times, or it doesn't fit a whole number of times because it's a bigger fraction than it. All right, let's go ahead and try out number 8 here. For number 8, we have 15 over 22 divided by 45 over 33. Right off the bat, we do really like that they're both in improper form, so we don't have to do any converting forms here. So let's go ahead and just rewrite this as a multiplication problem. So we're going to keep this first fraction, change division to multiplication, and then flip this fraction upside down. So we'll have 15 over 22, and change the division to multiplication. And let's go ahead and flip this second fraction, or write the reciprocal of it, and that's going to be 33 over 45. All right, so we have some multiplication to do here. We're gonna get some bigger numbers. So let's do 33 times this 15. So 33 times 15. 5 times 3 is gonna be 15, carry the 1. 5 times 3 is 15, carry 1 is gonna be 16, so 165. Put a placeholder here. 1 times 3 is 3, and 1 times 3 is 3. we go ahead and add these two partial products together, we're going to get 594. So we're looking at 495 for the numerator. And what about the denominator? Well, we have 22 by 45. And let's see, 5 times 2 is going to be 10, carry the 1. 5 times 2 is 10, carry the 1, or add the 1 rather, is going to be 11. So that's one partial product. Put a placeholder, 4 times 2 is 8, and 4 times 2 is 8. So it looks like if you add these partial products, we're going to get 0, 9, and 9. So that's going to be 22 times 45. So we're going to put this 990 in the denominator, and I can see if we can simplify. I think we definitely can. This number ends in 5, ends in 0. So let's go ahead and take this 495 and this 990 here. Let's go ahead and divide them both by 5, right? Now if we take this 495, and again, if you need to pause and do some long division here, this is going to go in 99 times. And if we take this 990 here, 990 divided by, let's see, 990 divided by 5 here is going to be 198. Okay. Now if you look at this 99 and 198, if you add their digits, 9 plus 9 is 18, and 1 plus 9 plus 8 is also 18. So we can divide these both by 9. So it turns out 9 goes into 99 11 times, and then 9 goes into 198 22 times. At this point, you're going to look at 11 and maybe think it's prime, which it is, but 11 does go into 22, so you can divide these both by 11, right? So we're going to end up with 1 and 2, or 1/2 here. All right, so this did simplify down quite a bit here. If we go ahead and find out the GCF, it's going to be these numbers on the side. So it's going to be 5 times 9 times 11. So it's going to be 45 times 11. So our GCF here is quite large. They had a lot in common. It's actually divided by 495 and divided by 495. If you go ahead and look at our leftover numbers at the bottom, that's actually our quotient here, or the answer to this division problem. And so this whole thing just kind of simplified down to just being 1/2. All right, cool. Let's move on to number 9. For number 9, we have a mixed number divided by another mixed number. So we have to do one more step here. I know, I'm sorry. But let's go ahead and do big bottom plus the top here. So for this first fraction, 4 times 5 is 20. That's big bottom. Big times bottom plus the top. Plus 4 is going to be 24. So we're looking at 24 over 5. I'm going to keep this written as a division problem, okay? Let's take this 24 over 5, and let's go ahead and divide that by the improper version of this second fraction. So 7 times 7, big bottom is going to be 49. 49 plus the 5 is going to be 54. So we're looking at 54 over 7. Okay, so that's going to be the same division problem, just rewritten so we have improper fractions. Next, if we go ahead and keep, change, and flip, just to rewrite this as a multiplication problem, we're going to keep this 24 over 5. We're going to change division to multiplication, and we're going to flip the 54 over 7 and make it 7 over 54. Okay, now let's go ahead and see what's going to happen if you go ahead and multiply these together. So just a little more space here, but 24 times 7, there's going to be 7 times 4 is 28, carry the 2. 7 times 2 is 14, plus 2 is 16, so the numerator should be 168. And then for the denominator, we have 54 times 5. And then we're going to get 5 times 4, which is 20, carry the 2. 5 times 5 is 25, plus 2 is 27. So our denominator here is going to be 270. Okay, so we have some pretty large numbers again here, but let's go ahead and use our divisibility rules to help us simplify this as much as possible. So we have 168 and we have 270. Let's see, they both are even numbers, so we're going to divide them both by 2. Half of 168 is going to be 84, and half of 270 is going to be 135. Now, you can't divide these both by 2 because one's an even number and one is an odd number. However, you can check to see if they're divisible by 3. So 8 plus 4, that's 12. 3 does fit into 12. And 1 plus 3 is 4. 4 plus 5 is 9. And 3 does fit into 9. So we can divide these both by 3. If you go ahead and take this 84 and divide it by 3, feel free to pause if you need to. That's going to be 28. And 135 divided by 3 is going to be 45. Now, 28 and 45 are smaller numbers here. 28 is its prime factorization is 2 times 2 times 7, and 45's prime factorization is 3 times 3 times 5. So they don't have anything in common here. So our GCF here is 6. So if we go ahead and divide the numerator and denominator both by their GCF, what are we going to get? Well, don't go ahead and actually do that division, because we're going to end up here with this 28 over 45. All right, so that would be the quotient, or the answer to this division problem. We would just say this would be 28 over 45. Okay, cool. So that was number 9. Let's go ahead and try a few more here. Hopefully this is getting a little better as you go. And again, as always, feel free to pause as you need to so that you can think and understand the process. All right, so for number 10, it looks like we have a mixed number divided by a proper fraction. So let's turn this mixed number into an improper fraction. So 1 times 35 is 35, plus the 1 on top is going to be 36. So we're going to have 36 over 35. Let's go ahead and divide that by this 20 over 63. We don't have to do anything with this one because it's already a proper fraction, right? Now let's go ahead and rewrite this as a multiplication problem. So we're going to keep, we're going to change, and we're going to flip. So let's go ahead and rewrite this as 36 over 35 times, and we're going to flip this fraction or write the reciprocal, and that's going to be 63 over 20. Okay, so these are going to have some large numbers again, so let's go ahead and just practice our standard algorithm. But for the numerator, we're going to have to multiply 36 times 63, and for the denominator, we're going to do 35 times 20. So if you want to pause and do that quickly, go ahead and do so. But we're going to have this 36 by 63. Okay, and 6 times 3 is 18, carry the 1. 3 times 3 is 9, plus 1 is going to be 10. We're going to put a placeholder here. 6 times 6 is 36, carry the 3. And then 6 times 3 is 18, plus 3 is 21. So if we go ahead and add these two together, we're going to have 8, 6, 2, and 2. So our numerator here is going to be 2,268. What about the denominator? Well, for the denominator, we have 35 times 20. Well, 35 times 2 is going to be 70. And 70, if you put another 0 on after, is going to be 700. So I'm just going to put 2268 over 700 here. Again, if you want to pause and do the multiplication, feel free to do so. All right, so what could we divide both of these numbers by? Well, they're both even numbers, so we definitely know we can simplify here. So let's start with just 2, right? If you go ahead and use 2 on the side, just divide that 2268 divided by 2. Again, feel free to pause to do that. We're going to get this 1134. Hopefully that also just makes kind of intuitive sense. 700 divided by 2 is going to be 350. Okay, let's go ahead and see if we can do this again. I think we can here. Now these are both even numbers, so we can go ahead and just divide these both by 2 here. So if we go and take 1134 and divide that by 2, you're going to get 567. Okay, 567. And if you take 350, this 350 divided by 2 is going to be 175. All right, so these are still pretty large numbers here. It looks like I'm running out of space. I think we might be able to do this again, if I'm not mistaken. These are pretty big numbers. I don't think you can divide them by 2. I don't think we can do 3 or 4. 5 won't work. 6 definitely won't work because they're both odd numbers. 6 only works if they're even numbers. 7's always a tricky one. Let's see. If I take this 7 and double it, that's 14, right? So if you take away 14, that's going to be 42. Now 7 does fit into 42 nicely, so this does divide by 7. If you take this 5 and double it, it's 10. And if you subtract 10 from 17, you get 7. So actually, this is a multiple of 7 as well. So you can actually divide both of these numbers by 7. And I'm just going to go ahead and draw an arrow here because I'm running out of space. And if you take 567, and divide that by 7, that's going to be 81. And let's see, if you take this 175 and divide that by 7, that's going to be 25. Now 25 only breaks into 5 and 5. 81 breaks into 9 times 9, which is 3 times 3 times 3 times 3. So I don't think they have anything in common here. So what was our GCF? It's 2 times 2, which is 4 times 2 is 7. That's 28. So turns out you could have divided both top and bottom by 28 here. And what would you be left with? Well, don't actually do the division, all right? The top would be 81. Let's go ahead and write that. It's 81. And what would the bottom be? The bottom would be 25. Now, as a mixed number, 25 fits into 81 3 times. I'm not going to do that division just because 25 plus 25 is 50, 50 plus 25 is 75. I can't get closer to 81. 75 is 6 away from 81, so it's going to be a remainder of 6 out of 25. So we can write our quotient here, or answer to our division problem, as 81 over 25, which is equal to 3 and 6/25. Okay, that would be our answer here. Let's go ahead and see if we can try number 11. So for number 11, we have a mixed number divided by another mixed number. So let's go ahead and rewrite them as improper fractions first. So again, if you want to pause and give that a go, feel free to do so. But 3 times 9 is going to be 27. 27 plus 8 is going to be 35. So we're looking at 35 over 9. Let's go ahead and divide this by our second mixed number as an improper. So 5 times 5 is going to be 25, plus a 3 is going to be 28. So we're looking at 28 over 5. Perfect. All right, so we have improper fractions. So let's turn this into a multiplication problem by keeping, changing, and flipping. So the answer to this division problem is also going to be the answer to this newly written multiplication problem. It's going to be 35 over 9 times 5 over 28. I'm actually going to put this over here so I have more space to do the multiplication. 35 multiplied by 5 on top, that's going to be 25 plus this 2 on top here. 5 times 3 is 15, plus a 2 is going to be 17. So our numerator here is going to be 175. What about our denominator? We have 28 times 9. So 9 times 8 is going to be 72. Carry the 7. 9 times 2 is 18, plus 7 is going to be 25. So we're looking at 252 here. All right. Let's see if we can go ahead and simplify here. So let's take this 175 and this 252. And let's see, what can you divide these both by, if anything? Let's use our divisibility rules. I don't think you can use 2 because that's odd and that's even. What about 3? Well, 1 plus 7 is 8. 8 plus 5 is 13. So that already fails for 3. I can't use 4 because 2 failed, so no even numbers. 5 works for this one, but it doesn't work for this one. 6 only works if it's even. 7, let's try 7 again, I guess. So take this 5 and double, it's 10. So subtract 10, that's going to be 7. So 7 could work for this one, or it does work. And you take this 2 and double, it's 4. So 25 minus 4 is 21. Oh, and that's a multiple of 7 too, right? So we could actually divide this by 7. So 175 divided by 7 is going to be 25. And if we take 252 and divide that by 7, that is going to be 36. Now 25 just breaks into 5 and 5 here, right? And that can't be broken down more. 36 breaks into 6 and 6, and 6 breaks into 3 and 2, and 6 breaks into 3 and 2. So notice they have nothing in common here. All right, so I think we're all done. Our GCF here is just going to be 7. So these are both divisible by 7 here. And then what are we left with for our quotient? Our quotient here is going to be just this 25 over 36. So I'm going to go ahead and write that as 25 over 36. Let's go ahead and change the color here like we did earlier. So 25 over 36. And that's a proper fraction, right? So we don't have to go ahead and turn that into a mixed number or anything either. So that would be our final answer. All right, let's try one more problem. For number 12, we have a mixed number divided by a proper fraction. So let's turn the mixed number into an improper fraction first. So 2 times 4 is 8, plus 1 is going to be 9. So we really have this 9 over 4 divided by this 21 over 25. All right, cool. So now that we have propers and impropers, let's turn it into a multiplication problem. So let's keep, change, and flip. So this will be 9 over 4 multiplied by 25 over 21. All right, let's see what the numerator is going to be. We have 25 multiplied by 9. And let's see, 5 times 9 is going to be 45, carry the 4. 9 times 2 is 18, plus the 4 is going to be 22. So we're looking at 225 for the numerator. Okay, and then for the denominator, we have this 21 times 4. So 21 times 4, 4 times 1 is going to be 4, and 4 times 2 is 8. So we're looking at 84 down here. Okay, so let's see, can we simplify this fraction? I think so. Let's take this 225 and 84. We should always try, right? We can't divide them both by 2 because 225 is odd, but maybe 3. 2 plus 2 is 4. 4 plus 5 is 9. So you can divide this by 3 and 9. And 8 and 4 make 12. So that divides by 3, but not 9. So 3 they have in common. What is 225 divided by 3? That is going to be 75. And what's 84 divided by 3? Well, 84 divided by 3 is going to be 28. Let's see, 75 will break into what, 5 and 15. 15 breaks into 5 and 3, so that's its prime factorization. 28 has 7 and 4. 4 is 2 and 2. So they have nothing in common here, so I think we're all done. Our GCF here was simply 3, which means you can divide the numerator by 3 and the denominator by 3. And if you go ahead and do that, again, don't do the long division or anything. We have the quotient right here. It's going to be 75 over 28. All right, if you wanted to go ahead and write this as a mixed number here, 28 is going to fit into 75. How many times? I think 28 is going to fit into 75 2 times. So let's go ahead and actually get rid of this fraction bar here. Let's put a 2 here. What is 2 times 28? 2 times 28 is 56. So if it's 56, I think we are going to be 19 away. I think it's going to be 19 over 28. Let me actually just double check that real quick. I don't want to say something that's not correct here. So 28, if we put a 2 here, 2 times 28 is going to be 56. If we subtract here, we have to borrow. It's 15 minus 6 is 9. 6 minus 5 is going to be 1. So 19 is the remainder here. Okay, cool. So our quotient here is going to be 75 over 28. But you can also say this would be the same thing as 2 and 19 28ths here. All right, so there you have 12 different practice problems. The first 6 were about multiplying fractions, simplifying when we were done. And the second 6 problems were about dividing fractions, but we have a nice little algorithm. So if you know to keep, change, flip, you can rewrite all division problems as a multiplication problem and then solve it as we did with the first 6 problems. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and letting your classmates or friends also know about this video to help them out with their problems. And as always, keep up the great work that you're already doing.